they sent you this oleocanthal molecule to do some bench work with, and what was discovered?
So first of all, the most interesting thing was that it initially we tested it on cells in a dish. And what we noticed was that it causes really rapid cell death that I have not seen with any other compound. The compounds you throw bleach at cancer cells, that it would kill them, it would kill anything. But as far as organic, natural compounds, it caused very rapid cell death. You could see it with your eyes in a microscope. You didn't have to do any kind of fancy assays. And that was interesting because mostly when we work with cancer cells, we always think about apoptosis as a mode of death. And apoptosis takes some time to achieve. It's actually a pathway that involves several reactions that have to happen in a certain timeline. But this was much faster. Something was happening to those cells that made them almost die from the inside out. And that was interesting. And that is one of the first things I said to figure out what's happening there, what's killing the cell, how does oleocanthal kill the cells? And again, I'm not saying it happens with every cell or not even with every cancer cell, but what we found is that it affects a very important organelle inside the cells. We all have, in every cell in our body, we have these organelles called lysosomes. And lysosomes often are referred to as the recycling centers of the cells, but they're much more than that. Basically, for cells that are in an environment where they are very poorly vascularized, as is the case with many tumors, especially in the early stage before they get blood vessels feeding them, the cells need a way of getting nutrients, and they don't have that way of getting nutrients. So what happens is they recycle internal components that are not necessary anymore of the cells in their lysosome through a process called autophagy. And very often, autophagy is a survival signal for cells, for cancer cells. So often with chemotherapy, when some tumors become resistant to chemotherapy, the reason for that is because they activate their autophagic pathways and are able to survive. They're able to exclude those toxins from the cellular environment because lysosome can shuttle some materials out of the cell, and they're able to use nutrients that already exist in the cell for survival. So when we target lysosomes, as we found that oleocanthal does, it really targets lysosome and poke holes in them. It makes them not very effective anymore. It affects cancer cells much more than normal cells, because normal cells, they still need the lysosomes, but not as much as some cancer cells do.
And so even in the lab, putting this directly on cell cultures or whatever, what was the effect on healthy cells? Did it kill healthy cells at all?
Not in the same concentrations. You need a concentration maybe 15, 20 times higher in order to start affecting healthy cells, which is what you want when you look at compounds that you can use to fight cancer. You're looking for the differential. If it only took double the amount to kill healthy cells, that wouldn't be very interesting. But there's a really big differential between the dose that killed cancer cells and the dose that killed healthy cells.
Yeah, that's really important. And you mentioned bleach earlier. It's like, yeah, bleach kills cancer cells in the lab, and if you drink bleach, it'll kill cancer cells. But bleach is like chemo.
Yeah,
you're gonna kill a lot of healthy cells if you drink some bleach.
I agree. And unfortunately, for many patients, sometimes oncologists prescribe things that are like almost as bad as bleach.